So hello guys, today we are going to do a leetcode question that goes by the name minimum number of operations to make word k periodic. Question number is 3137 and it's a leetcode medium question. So following the pattern, what we'll do is we'll first try to read the problem statement and then we'll go on to the solution. Okay, so let us first try to read the problem statement and interpret what it is trying to say, and then we'll go on to the solution. So let us start. You are given a string word of size n and a string and an integer k such that k divides n. Okay, so I am given a string, and I am given some integer k. This is an integer, and I am given that this k is a factor of n. Okay, so if n is the word length, then this k should be a factor of this n. Suppose basically if this n is 8, then k should be 1, 2 or 4. Okay, or it can be 8 also. So k should be factor of n, or n should be divisible by k exactly. Okay, so this you are given. These are the two things that you are given. In one operation, now it is given that what you have to do. In one operation, you can pick any two indices, I and j, that are divisible by k. Okay, then replace the substring of length k starting at I with the substring of length k starting at j. That is, replace the substring word of I plus k minus 1 with the substring word of j plus k minus 1. Return the minimum number of operations required to make the word k periodic. So let us consider this k periodic is something, okay, but it is something. We'll try to interpret what it means, but for now we'll try to understand this paragraph, what it is trying to say. Okay, suppose I consider the first use case this. So see, okay, the length of the substring, length of the string is 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11 and then 12. Okay, 11 basically. So the length is 12. There's 4 plus 4 plus 4. Okay, I am said that you choose one index such that the index you choose should be divisible by n, should be a factor of n basically, So what are the indices that I can choose? See, it is given that are divisible by k, I and j that are divisible by k. So in this case, what is my k? My k is 4. Okay, so it should be divisible by k, or it should be a multiple of k. So I and j should be a multiple of k. And I am given the range from 0 to 12 or 0 to 11. So what are the indices I can choose? What are the indices in this range that I can choose? Starting at 4. Remember, starting at 4. So I can choose 4, or I can choose 8, or I can choose 12, but 12 is out of index, out of bound. Okay, we'll talk about it. So this is the first index that I can choose. So my string can start at this and 0 also. So my string can start at this, and my string can start at the 8th index. This is the 8th index. My string can start at this. Let's try to rewrite them. This is 8, 9, 10 and 11. Okay, so this is my 8th index. The string can start at this. So this can be a substring that I can consider, or this can be a substring that I can consider, or this can be a substring that I can consider. So these are the 3 substrings that I can consider. Remember, the index I and j that you are choosing should be a multiple of k. And all the substrings that you choose start at this index I and j. Okay, now what you are given is, you have to make the string. Okay, now what you are given is, first you are given with the string and this integer, and you were given with the second condition that you have to take only the substrings that are starting at index I and j, and this I and j should be a multiple of k. This I and j should be a multiple of k. Till now we have understood. Okay, till now we have understood. So, and what you are given is basically what you can do is, suppose this is my substring, this is my string, and I have three substrings in this, one this and this. What I can do is I can basically choose this substring and I can replace this substring with this substring. Okay, so it could be like leet code. So this code will be eliminated and this leet would take its place. Okay, so we can basically replicate a substring. Okay, replicate a substring. Okay, leet and then leet. Or I could do this also if I am given with this leet code leet and I have three substrings. Code leet and I have three substrings. First this and this. I can also delete this leet and leet, and instead I could just put my code here and code here. Basically copy the second substring to all the substrings, to any substring basically. Okay, so you can do this. Okay, return the minimum operations required to make the word k periodic. So this one replace is taken as one operation. Okay, you have to do the minimum operations such that you make the string k periodic. Okay, now what is k periodic? See, it is given, we say word is k periodic if there is some string s of length k such that word can be obtained by concatenating s an arbitrary number of times. For example, AB, then word is 2 periodic for s is equal to AB. What is this trying to say? Suppose your word is something like AB. Okay, so as you can see, AB is repeating, this AB is repeating, this AB is repeating, this AB is repeating. So the number of characters repeating, this is known as k periodic. Okay, suppose in this, if I have leet and then leet, as two letters are repeating, this is 2 periodic. Okay, now if I have this and obviously my k is equal to 4 in this case. Okay, so this would be 4 periodic, as 4 length strings are repeating again and again, this leet. Okay, so you have to make your given string equal to this k periodic string in the minimum number of operations. Okay, minimum number of operations. Basically, if you are given with this leet code and then leet, so these are the three substrings, and you could replace any substring with any substring. This I can put here, this code I can put here, this leet I can put here, but you should be following a pattern that the whole string contains the same substring, okay, is repeated again and again. Like the string should be made a concatenation of this k length substring. Okay, k length substring. So if I would be making it to 4 periodic, the string would look something like leet and then leet. So it would be 4 periodic string. Okay, so how can I do this? What is gonna be my approach? Okay, first what we have to do, see, you are given with some string. So first you will need to find all the substrings, all the k length substrings, because if you don't have the k length substrings, how you will swap with one another, or how you will replace them with one another. Okay, so first you will need to find the substrings of k length. Okay, after you have found out all the substrings, the second thing is to find out the minimum number of operations such that only one substring is remaining in the whole string. Okay, basically if it is something like A, B, C, D, so this AB can be replaced with this CD. Okay, and this AB. Okay, so if it is too periodic, how can I make the string concatenation of a single substring? Just see AB, then here should be AB, then AB. Okay, so it is a concatenation of the substring AB. How can I make this? Just replace my CD with AB. Okay, so I have to find the minimum number of operations such that I can make the string k periodic. I can make the string k periodic. String k periodic. Okay. First we'll try to figure out how I can get the substrings, then I'll tell you how to get the minimum number of operations. Okay. Suppose you are given with this string A, B, C, D and then A, B. Okay. I'll just write down the indices. Indices are basically 0, 1, 2, 3, 4 and 5. Okay. The string length is 6. String length is 6. Suppose my k value is 2. K value is 2. So where should I split the strings? Where should I split the strings? This k is equal to 2 means each substring would contain only 2 letters. Each substring would contain only 2 letters. Okay. So when I get 2 letters, I should stop. Okay. So if I just start from the first index, see, when I get 2 letters, suppose I start from here, I get 2 letters, I stop. I consider it as a substring. Okay. Then again I come forward. Then I again detect 2 letters, I consider it as a substring. Okay. I again come forward, I consider 2 letters because my k is equal to 2. Now I consider it as a substring. So there are 3 substrings in this whole string. That are following my condition. Okay. So how can I implement this? Basically it looks kind of easy. See, if I am given with something like this ABC, then I am given with DEF, then I am given with ABC, or I am given with something like ABC, then ABC, then DEF. Okay, and I am given with k is equal to 3. So whenever I will detect 3 characters, I'll consider it as a substring. Then I detect 3 characters, I'll consider it as a substring. Then I detect 3 characters, I'll consider that as a substring. Okay, and it is always being followed because I am given in the question that my n would be exactly divisible by k. Okay. So how can I implement this? See, A, B, C, D, A, B, and you are given with this indexes 0, 1, 2, 3, 4 and 5. Okay. Suppose you are starting with the first index, that is the 0th index. Okay. You are given with k is equal to 2. So all your substrings should start at a multiple of 2. At a multiple of 2 because see, only after the length 2, like from 0 to 2 would be one substring, 3 to if consider this 0 based indexing, then 0 to 1 should be one substring, 2 to 3 should be second substring, 4 to 5 should be third substring. Okay, and if I consider index wise, then all the multiples of 2 should be the starting index of a particular substring. Okay, be it be 0, 2 or 4 in this case. So these will be the starting point. Of my substrings, and that is the case also. Okay, because see, 0 to 1 would be one substring. What I'll do is I'll make an empty substring. I'll make an empty string at the start. Okay, not for the first case, excluding the first case. Whenever I get whenever I get an index that is a multiple of 2, whenever I get an index that is a multiple of 2, what I'll do is I will store this substring into my vector. Suppose I'm storing it in my vector for now. Okay, so I'll store this into my vector AB. This AB is stored in my vector. Okay, this AB is stored in my vector of strings. When I'll come to the second index, what I shall do is, shall I include this C with my previous string? No, because see, this 2 is a multiple of 2. 2 is exactly divisible by 2. So I should clear this string. This string should be empty when I come to this index, and I should include this letter. I should include this C. So my string should now contain C. Okay, I'll go forward. I'll include this. So CD would be my string. I'll come to 4. I'll again notice that 4 is a multiple of 2. 4 is a multiple of 2. What I'll do is, I'll again add it to my vector. I'll again add it to my vector. So my vector gets CD. Okay, and I'll clear the string. So my string would become empty, but I'll then add this character, because if I don't add this, will be moving to the next index without adding this character. So this character would be skipped. So this string would contain A. Now. Now I'll go to this index. Okay, it is not a multiple of 4. It is not a multiple of K. I'll simply add it, and I go forward. You will see that this string is not empty. This str is still not empty. It has some string. And as my n is exactly divisible by k, this string should be valid. So I'll have to make a condition at last that I'll add this. Basically, I'll add the last string also. Okay, because otherwise it will be skipped. So this is the edge case in the string, in the substrings that we are finding. Okay, and we have to make sure that when we are emptying the string's data, then the index should not be equal to 0, because it is already 0 and it should not be added to my vector. Okay, I'll just try to show you A, B, like C. What I'll do is, I'll simply declare my string in the start. What I'll do is, I will move from my 0th index to the string last, str.length, the string that is given basically. So s.length, we shall consider it s.length, and I++. What I'll do is, if my I is perfectly divisible by k, if my I is a multiple of k, just consider this string as an example. Okay, 0, 1, 2, 3, 4, 5. Suppose I am at this index. What I shall do is, as this is my starting point, first I have to make sure that it is not divisible, it is not equal to 0. Why? Because if I am at the 0th index, it is divisible by k, but my string is empty. So I shall not do any operation. Okay. Else, if I am at any other index that is a multiple of k, what I have to do, just empty my string, but before emptying, just add it to the vector. So it gets stored. Okay, and after emptying, just add the current character to the string. Okay. Else what you need to do, basically just increase your string length. Okay, s of I. Okay, so you will be able to find all the substrings with this code. You will be able to find all the substrings. You will be able to store it in a vector. This V is basically vector of strings. Okay, vector of strings. So we are done with the first part. what was the first part? Finding out all the substrings. Finding out all the substrings. Now what is the second part? What is the second part? What we have to do? We have to find the minimum number of operations, such that I can make the string k periodic. I can make the string k periodic. Okay, I can make the string k periodic. I'll tell it with an example. Okay, see, when you are given with this a b c d a b, okay, suppose you have k value equal to 2, and if k value is equal to 2, you have these substrings. This is my substring, this is my substring, and this is my substring, and it is given that you can replace any substring with any substring, with any substring. Okay, and you have to find the minimum number of operations to make the string k periodic. Okay, so when I can do minimum number of operations, just try to think like that. When can the operations be minimum? When can the operations be minimum? When can the operations be minimum? That can only be minimum when the replacement is minimum. And when can the replacement be minimum? Suppose I identify the substring that is occurring the maximum number of times, and I try to replace all the other substrings with this max occurring substring, then the number of operations would be minimum. Replace all other substrings with the max occurring substring. Okay, just try to think like that. Suppose A, B, C, D and AB. Okay, these are my substrings, and I'll just record the frequency of each of the substrings. Suppose my AB occurs twice, CD occurs once. Now I have two operations. Either I can replace all the ABs with CDs, but if I do this, the operations that I would take is 2, because see, the CD is only 1 and AB is 2. And if I have to make a pattern like this, CD, CD and CD, what I'll have to do is I'll have to replace this AB and AB with CD, and that is gonna cost me two operations. But consider a case where I replace instead of replacing CD to both the like AB with CD, what if I replace the CD with AB? As my AB is in abundance, that is the maximum occurring substring. Okay, so if I replace this AB, this CD with AB, I would take only one operation. Okay, and this would take me two operations. So what is a better choice? I have to return the minimum number of operations. So what is the better choice? Obviously, this one operation. Okay, this one operation. Why this is occurring? Because see, if in a substring, suppose this is you are given. Okay, leet code and then leet. Okay, and you are given with k is equal to 4. First, I'll just try to know all the substrings. So these are the three substrings. I'll record their frequencies. Leet is occurring 2 times, code is occurring 1 time. Okay, so the total number of operations, total number of occurrences is 3. Total number of occurrences is 3. Okay, what can be my two choices? Either I can replace this both of these leads with code. Okay, so this can be my string, this can be my resulting string, or I could replace this code with lead. Okay, and this would result only in one operation, because lead is already occurring maximum number of times. Lead is already occurring maximum number of times, and if I choose any other string instead of this would be resulting in a loss. Why? Because the number of operations would gradually increase. Okay, if in my substring there is already maximum number of substrings that are occurring, this lead is already occurring 2 times. Why would I replace it? Why would I replace this? I would replace the one with the minimums, right? With the minimums, and I would use this maximum. I would use this maximum to replace all the other minimum substrings. Okay, I'll take this test case. Second one, leet co-leet. Okay, leet co-leet. In this case, my k is equal to 2. First, I'll try to make all the substrings. So first substring is first two characters, then this, then this, then this, then this. Okay. Now I'll try to record the frequency. So LE occurs 1 time, ET occurs 1 time, CO occurs 1 time, LE occurs again. So yes, LE occurs one more time, and then we come to ET. So ET also occurs one more time. Okay, so LE has an occurrence of 2, ET has an occurrence of 2, CO has an occurrence of 1. Okay, now what I can do is I can choose any of these 3 strings to replace. Okay, either I can choose this string, this first string, and I can replace all the other strings, because this is what I have to do. I can choose only one substring. Okay, or I can pick up this substring and I can replace all the substrings. Okay, and one replacement takes one operation. Just try to remember, I have to minimize the number of operations. Okay, or I could choose this substring and what I can do is I can replace this. I can replace this LE with CO and I can replace this ET with CO. Suppose I choose this LE as my answer. We'll try to analyze all the 3 cases. Suppose I try to replace LE, okay, like all the other substrings with LE. So LE remains intact. This ET becomes LE. This CO that takes one operation. Okay, this CO becomes LE. That takes another operation. This LE stays LE. Okay. This ET takes one operation, so this is count becomes 3. Okay, this count becomes 3. Okay, so in the first case I got my count as 3. Now I'll try to consider the second case where I take ET and I'll replace LE and CO by ET. Okay, so first substring LE, my count is 0 initially. LE will be replaced by ET, so yes, it takes one operation. LE will be replaced by ET. Okay, second, ET is there, ET remains intact, no operation is needed. CO will be changed to ET, so there will be one operation. My count would increase by 1. LE is present again, so it will be replaced by ET, and yes, it takes one operation. Last substring is ET, and when I come to ET, this doesn't take any operation, so the count still remains 3. Okay, in this case also the count comes as 3. In the third case, where I have to use CO as my substring that will overtake all the other substrings. Okay, so this ET will be replaced by CO and LE will also be replaced by CO. In the third case, just try to see. Okay, CO has a lesser occurrence, lesser frequency. So if it has a lesser frequency, if it is present already very less, it is present in already very less quantities, so I have to uh, the number of operations will be maximized, because now this will also be have to convert it to CO, this will also have to be converted to CO. Okay, you just try to see, this LE will be converted to CO, so count was initially 0, and when this LE comes, okay, I'll replace it by CO, so that takes one operation, okay, my count would be 1. I come to ET, ET would also replace by CO, that takes another operation, count would be 2, CO remains intact, okay, count doesn't increase. I come to LE, it would also be replaced, so count still increases. I come to ET, ET should also be replaced by CO, so it would also increase my count. So as these both has the frequency, had the maximum frequency, they had the least count, or they had the least number of operations. That is because they are already present in so much quantity that the other strings, the operations becomes minimized, because now I don't have to replace my strings. But if I choose a string that is already in less occurrence, then the number of substrings that will be replaced by that particular string will be more, obviously. Okay, because if it has less occurrence at the start, then all the other substrings would be replaced. Okay, but if it is present in so much quantity, then the number of substrings to be replaced significantly reduces. Okay, so what I have to do, basically I have to figure out the maximum occurring frequency. I have to figure out the maximum frequency, and what I'll do is I'll replace it from total frequency count. Okay, that means sum of all the frequencies basically, minus the maximum frequency. Sum of all frequencies minus the maximum frequency. Okay, why? Because see, all the others, okay, because this represents the substrings frequency, okay, and this represents total frequency, like all the substrings, and this is excluding the maximum one, like basically we are excluding the maximum one, and all the others are to be changed, okay. So supposing AB, CD, AB has a frequency of 2 and CD has a frequency of 1. What is my total frequency count? Total frequency count is 2 plus 1, that is 3. Okay, and what is the maximum frequency count? That is 2. So 3 minus 2 would be 1, and that is what? I have to replace only one substring in this case. I have to replace whether if I have chosen the CD as my maximum frequency, or okay, so 3 minus 1 would be 2, and I that means I have to replace these two strings with my CD. That is not an optimal approach. This is not I am looking for. Okay, so what I'll do is sum of all frequencies minus the maximum frequency, because the maximum frequency, the substring with the maximum frequency is the most ideal one. Okay, it's the most ideal one. Okay, because it is already occurring so much times. Okay, and other substrings would be occurring obviously less than it, so the number of operations would significantly reduce. This is the best case that can be followed. Okay, now I'll try to code down the approach for you, but before I'll try to summarize what we did. We first found out all the valid substrings, okay, and instead of storing in a vector, I'll store it in a map. So I have the frequencies of all the substrings, and so I'll make a map of string and int, okay, and I'll store the substrings with the frequencies. Suppose ABC occurs 2 times, CDE occurs 3 times, and stuff like that. Okay, just I have to remember about the first case, I is equal to 0, and the last case, I is equal to n. Okay, because these are the two cases where my substrings would not be recorded. Okay, so I have already explained this, and I'll repeat this when I code. Okay, Now I have find out all the substrings. Now what I'll do is I have to find out the minimum number of operations. Minimum number of operations. Okay. So these are the two steps that we did. Now I'll try to code it down for you. What we first need is we need an unordered map that will be of string and int type. Okay. Then what I need? Okay. I will be traversing from the 0th index to the last index okay, and I know that if my I is percentage k equal to 0, that is basically if a b c d a b, this is basically this index where my string should be emptied into the map, where my string should be stored in the map. Okay, so my map would be updated at this case. Okay, so it will be updated in all the cases except also I need an empty string before. It would be updated in all the cases except when my I is equal to 0. So mpp of str plus plus. Okay, mpp of str plus plus is what I'll do is I'll simply empty my string. Before after emptying, what I'll do is my current element should be pushed. Because if I don't push it, then the current element will be missed. Because see, if I am storing at the C index my lead string, then this C would be ignored if I don't store it in my string. Okay, so S of I. Okay, and in all the other cases, what I have to do is I simply have to push back my current index element. Okay, so in this process what we have done is we have updated our map with all the substrings and their frequencies. Okay, all the substrings and their frequencies. Now if I'll just show you, see, try to run and show you all the substrings that would be occurring. So this is word of I. Okay, so see, this co is occurring one time, this et is occurring one time, and le is occurring 2 times. Is this the scenario? Is this the same as what we recorded? See, le was occurring 2 times. Okay, le is occurring 2 times. Et is occurring 2 times. No, et is occurring only 1 time. Co is occurring 1 time. So what is missing? Et, one frequency of et is missing. And why it is missing? See, in this example, you, for this code, like, you will be ignoring the last string. Okay, if this is starting from index 8 and ending at index 11, when this 12 index occurs, my loop stops. Okay, so it will not be updating my string into my map, so I will have to explicitly write about this in the map. So this string will be recorded after the loop ends. Now I'll try to run it, then it will run successfully. Okay, it would be storing the correct frequencies. As you can see, et becomes 2. Okay, so now what we have done is we are done with the first part of the question. That was to identify all the substrings. Yes, I have identified all the substrings. I have the frequencies of all the substrings. Now what is the second part? Second part was to get the minimum operations. And what we told is, for getting the minimum operations, I have to identify the substring that is occurring the maximum. Because if it is already occurring the maximum, then the operations would be minimized. Because then there is the need for replacing other substrings reducers. Okay, so what I need is, I need the maximum frequency. So I'll make a mx equal to int min, so it can be updated, and I need the sum of all the frequencies, so I'll make sum equal to 0. Now I'll iterate through the map. I'll make sure to add my frequency in the map, and I'll make sure to update my frequency, update my maximum frequency. Okay. So now what should I return? Yes, sum minus mx, and why is that? Okay, now we are done with the second part also. So I'll tell you why sum minus mx, because see, all the frequencies, all the substring, this is one substring, this is one substring, this is one substring. Suppose this has the maximum frequency, so all the substrings frequency minus the maximum frequency, because maximum frequency will not be replaced. This will be replacing others. And this difference would give me the minimum number of operations. Okay. Minimum operations. So yes, I'll try to run it. Okay, I'll try to submit. Okay, submitted successfully. So yes, what we did in our question is basically we broke it down into 2 steps. Yes, I will be repeating the steps. Just we identified the substrings, then the minimum number of operations. And what we did in code is the exact same thing. Okay. You just have to know about this first, like I not equal to 0 test case, edge case basically, and this last edge case. Okay, because these are the 2 cases where your string should not be and should be updated. Okay, map should not be and should be updated. And in the second part, we are doing nothing, basically subtracting the maximum frequency from the total amount of frequencies. Let me talk about the time and the space complexity. So identifying all the substring, we are iterating only once. Okay, and maybe this map also. So total frequency becomes like total time complexity. What's the total time complexity? Suppose O of n and iterating all the substrings. So iterating all the substrings would simply give me n divided by k. So the time complexity becomes O of n plus n divided by k. Okay, I can basically ignore this, and my time complexity becomes O of n. What is my space complexity? Space complexity is, am I using an extra space? Let us see in the code. Yes, we are storing the string as well as the frequency. So the space complexity becomes O of n. So this was the overall solution of the question, minimum number of operations to make the word k periodic. I hope you guys like the solution. If you have any doubts regarding the solution, just bring it out in the comments, and if you like the solution, like, subscribe. Thank you. Have a nice day.